All right, good morning, good afternoon, whenever you're watching this, could be either or. We're going to start working on Unit 5, Lesson 10 through 12. We're going to be talking about solids, other solids, and their volumes. So go ahead and turn to a new page so that we can start. And I want you guys to title your page. So I want you guys to title your page Additional Volumes. Alrighty. So we've talked about other volumes in the past, right? So we've talked about our cube. We've talked about a rectangular prism. And we've also talked about cylinders, right? So far we have 3 that we've talked about. So go ahead and write these down. And each of these have unique volume formulas. We said that for a cube, it was going to be length times width times height. Kind of messed up right there. It should be a W. And so times H is equal to volume. Our rectangular prism should also be length times width times height for its volume. And lastly, a cylinder is going to be pi r squared times height is equal to volume. So as we're looking at all of these 3 volumes, we're going to add, I believe it's 3 more volumes that you will need for your test. So we're going to go ahead and start talking about volume of a cone. So go ahead and title that down, volume of a cone. And to start off, we're actually going to draw a cone. Doesn't have to be perfect, but I'm going to start by drawing a triangle and then connecting the bottom with an arc. Again, it does not have to be perfect, but you can pause the video so that way you guys can take your time and draw your drawing. I'm going to draw a dotted line from the top all the way down to the center of my circle of my base, and I'm gonna name it H. I also know that the very bottom part of my cone is my base. If we recall back to last lesson, I believe, we figured out that there was a generic formula for volume, and it was base times height is equal to volume. So with that being said, I'm going to look at my base here, okay? And I know that it's a circle. So because I know that it's a circle, I'm going to take the area of that circle, and it's going to be pi r squared, and then I'm going to multiply h, and that's going to give me my volume. But hey, right, if we look at our volume for a cylinder, it's the same as what we just wrote down for a volume of a cone. But there's actually going to be an extra part to this volume for a cone. We're actually going to write 1/3 in front of the pi. Why 1/3? Because if we took three cones and we put them together, they should form a whole cylinder. Okay, so we need to add this because um, it takes up 3 cones to make up a full cylinder, just like I said. So it's very important to remember putting in the fraction in front of the pi r squared times h for a cone. The good thing is that we know what pi r squared times h looks like. We just have to remember to put a 1/3 in front of it. Okay, so just like we always do, we're going to write down the volume formula of a cone. So volume of a cone, and it's 1/3 times pi r squared times h is equal to volume. So in your notebooks, please bubble this in, put it in a box or circle it, highlight it. You guys have your highlighters there with you guys at your tables. Please take the time to write this down because it is on your test. There is a question where you have to find the volume of a cone. So this is very, very, very important. So again, go ahead and highlight it. Make sure that when you're looking back at your notes, you know where you're looking for this volume formula. Okay. So in addition to the volume of a cone, I want to talk about the cross sections of a cone. This is also going to be on your test. So I kind of want to talk about it just a little bit. I know we've talked about it in the past, but I want you guys to have it in your notes. So we're going to draw another cone. Okay. Doesn't have to be perfect, but if you guys need to pause the video, go ahead and pause the video so that you can draw your cone. So I want to slice the cone horizontally. Okay. So that means that I'm going to cut it through here. It's like if I got a knife or a plane or an axis and just cut straight down the middle horizontally. If I were to do that, my cross section, so what I would see if I was standing on top of this cone and I cut the tip off, I would see a circle. Okay. So I would see the circle right here that I would shade in. If I were to take a look at the base, that's usually my cheat sheet when I am cutting horizontally. So if you look at your base and you see the shape of your base, that's usually going to be your horizontal cross section. So in this instance, we see that it's a circular base, it's a circle. That means that every cross section after that, that's horizontal, will also be a circle. So if I were to take another cross section below the green one, I would also have another circle as a cross section. So let's go ahead and write down my cross section is a circle. Right. So we talked about our horizontal cross section. I want to talk about our vertical cross section also. So let's draw another cone. This one is going to be on your test. This specific one, when it's being cut vertically, will be on your test. Okay. So if I take a knife and I horizontally cut it the way that I drew my plane that's cutting the cone, if I were to do that and drop it all the way down, I would be slicing it horizontally, and the bottom of that knife or that plane would hit down at the very bottom of the diameter of my circle, just like I just drew it right now. And I would actually get a triangle. But in this case, it would be a very special triangle. So it would actually be an isosceles triangle. Okay? I want you guys to underline isosceles triangle because that is the option that it will give you on your test. And I want you guys to remember that when you guys think about a vertical cross section of a cone. Okay? Go ahead and take a couple of seconds to finish up writing because we're going to move on to an example of using the volume of a cone. So this is example number 1, volume of a cone. Go ahead and draw a cone. Again, it doesn't have to be perfect. I'm going to draw the height from the top to the middle of the circle. The height is actually going to be 5, and then the radius is going to be 6. Okay, so the question is to find the volume. I'm going to write down my formula. This is also on your test, so please mark it as something important in your notes. So go ahead and start off by writing off the formula of 1/3 times pi r squared times h is equal to volume. I know my radius and I know my height. Okay, so I would have 1/3 pi times 6 squared times 5 is equal to volume. I will multiply my 6 times 6, which I get 36, times 5 is equal to volume. I'm down to 1/3 times pi, and then 36 times 5. 36 times 5 is 180 times pi. And bring down my 1/3. This is equal to volume. 180 times 1 is just going to give me 180, and I'm going to carry the pi over. Divided by 3. I'm only going to pay attention to the 180 and the 3. So once I divide those two numbers, I should get 60 pi. But I'm not done here. There's one thing I'm forgetting. So I should have 60 pi units cubed for my volume. Okay. We're going to keep practicing doing these solids. And if you guys have any questions, please write them down on the side so that way when I come back, I can answer them for you guys. Okay? So we're going to move on to a new shape. We're going to be talking about volume of a triangular prism. So go ahead and underline this part. I'm going to draw a triangular prism. It's a little bit difficult, but I'm hoping you guys can follow. Okay, so I'm going to start by drawing out a triangle. And then I'm going to draw 2 lines going straight down from each point. And then I'm going to connect these lines at the very bottom. I'm going to leave it like this for now. And I'm going to focus on the height of my triangular prism. My triangular prism is going to have a height of h, and my base is at the very bottom. So if I continue to finish drawing up my triangular prism, if I draw the very bottom part, my base, I should get a triangle. So my base is a triangle. All right, so I'm going to go ahead and write that down. So I want us to recall again that base times height was our original generic formula for volume. I want us to look at the base here, okay? And the base is a triangle, so I need to write the area of a triangle so that I can substitute it for B and be able to get my volume for this formula. So the area of a triangle, we've gone over it a couple times, not really at a large extent, but when we have seen it, we should write it as base times height divided by 2. And I'm going to draw a little triangle on the side to give you guys a reference of what that means. The base is at the bottom. Okay, so B stands for base. And then H stands for the height. Okay, and then I'm just going to divide it by 2 afterwards so I can get the area of my triangle. So my new formula should be B times H divided by 2 times H is equal to volume. And I know this is a little bit confusing and repetitive, but I promise we just need to practice a little bit, okay? So I want us to go ahead and write down, like we always do, the volume of a rectangular prism. So go ahead and title it out, volume of a rectangular prism, okay? So the volume of my rectangular prism is going to be base times height divided by 2 is equal to, times height is equal to volume. There's 2H. We just need to be careful which H we plug in into which H. Again, with practice, I hope that this just becomes second nature to us. Make sure to bubble this part in. This one is also on your test. If you need to highlight the formula for its volume, please highlight it. I'm not going to stress out how important these formulas are for your test. So please make sure you can find this in your notes. Okay? So now we're going to talk about the cross sections. Oops. I put rectangular prism and I should have put triangular prism. Making sure that I put the same thing on top. Okay, so now let's move on to cross sections. We are going to draw the same figure, the same solid, but we're going to be talking about the horizontal cross sections of our triangular prism. Okay, so take your time drawing this. I know it's a little tedious. If you haven't done it before, it takes a little bit of practice. So draw your triangle, the 2 lines in front. Connect to the bottom and try to redraw the same triangle at the very bottom. It's a little hard, but you can take your time with it. So if I were to cut horizontally through my line right here, and slice it, I would actually get a triangle. If I were to slice it across, I would get a triangle. Try to make this straight as possible. But I would get not necessarily a right triangle, but a triangle. It might look a little bit different depending on the figure that you get when you guys are doing practice problems. So if I do another one at the very bottom, it will also give me another triangle. So the horizontal cross section would be a triangle for my figure. Now if I want to look at the vertical cross sections, I'm going to go ahead and draw another triangular prism. Again, these are a little bit difficult to draw, so take your time. So if I were to have a plane, an axis, or a knife, and I were to cut through this vertically, I would actually get a line connected from the top to the bottom to the top, and the bottom to the bottom, and I should get a cross section of a rectangle. So my vertical cross section should be a rectangle. Okay. These are not going to be on your test, but it's important to just, keep them in mind if you do see them later on. So we're going to move on to example number 1. We're going to find the volume of the triangular prism. So again, go ahead and draw your triangular prism. It does not have to be perfect, but please take your time drawing this because it is your notes. So I'm going to label my height, and my height is going to be equal to 22. My triangle up top is going to have measurements of 13, 6, and 7. 13, 6, and 7. So I'm going to write down the formula for my triangular prism. It's going to be base times height divided by 2. And that whole thing is going to be multiplied by my other height, which is equal to my volume. Okay? So I'm going to look at my base, my B for my triangle, and it's going to represent 7. So I'm going to plug in 7. Then I'm going to look at my height, which is 6, and I'm going to plug in 6 for each, all divided by 2. So I've taken care of my base, which is my triangle. Now I'm going to locate my h, which is 22. So I'm going to plug in 22 for h. And now I'm going to multiply everything out. 7 times 6 is 42 divided by 2 times 22 is equal to volume. 42 divided by 2 is just 21 times 22. I multiply these out together, and I should get a value of 462 units cubed for my volume. Again, this is going to take a little bit of practice. I will be giving you guys a worksheet today to work on so that you guys can practice this out a little bit more. It is a little confusing because it has the 2 bases and the 2 heights, but with practice, I'm sure you guys would get it. Okay? We just need to train our eyes to look at the numbers that we need to look at to plug them into the formula. So the last shape solid that I want us to look at, it's called the rectangular pyramid. Okay, This one, I keep saying they're all hard to draw, but this one's a little bit harder to draw. So take your time with this also. If you need to stop and pause so that you can draw this out, go ahead and do that. So I'm going to draw a rectangle at the bottom. Doesn't have to be perfect, but my pen keeps deleting this. So I'm going to draw a diagonal line. They meet up top. From there, I'm going to go from the top to each corner on the other sides. And I get my rectangular pyramid. Okay. Again, we're going to recall our volume formula is base times height is equal to volume. I'm going to draw the the height of my pyramid from the top to the bottom part of the base, and this is going to equal h. Now the base is a rectangle, if I'm looking at it correctly, right? So the base is a rectangle. I know that the area of a rectangle is going to equal length times width times height. Length times width. So the area of a rectangle is length times width. I'm going to go ahead and plug this in for my base. So my formula should actually look like length times width times height is equal to volume. But hey, that kind of looks like the formula for a volume of a cube and rectangular prism, right? Which is true, but we're going to have to alter this equation also so that we can actually get the true volume of a rectangular prism. So we're actually going to add a fraction on top because we know that the cube and rectangular prism does not equal a rectangular pyramid. They're just not the same. It's not going to have the same volume. So what we're adding up front is going to be a fraction. This fraction is going to be 1/3. So I'm going to have 1/3 times length times width times height is equal to volume. And just like the cone, we're saying that it's 1/3 because it takes up 3 of these rectangular pyramids to create a cube. It needs 3 rectangular prisms to create a cube, and that's why we are multiplying it by 1/3. It's similar to the cone because for our cone, we need to take 3 cones in order for it to complete a cylinder. Okay. So, once again, we're going to go ahead and write down the volume of a rectangular pyramid. So go ahead and write this down. We're going to have 1/3 times length times width times height is equal to volume. Please bubble this in. Highlight it. You guys have highlighters there. This is important. You guys will also have this on your test. Sorry, I know there's a lot of equations, but I want you guys to practice, and remember these formulas. I haven't thought about if you guys are going to be able to use your notes or anything as a cheat sheet, but we'll see when we get there. Okay? So we're also going to talk about cross sections for this one, but This one is not on your test, but I want you guys to challenge yourselves and draw out your rectangular prism and see what would it look like horizontally and vertically. I also want to challenge you guys to do this on your own and then checking with a partner or two and see if they got the same cross sections. If they did or didn't, discuss and see which ones you guys would convince each other of what the cross sections would look like. Okay, so we're gonna go ahead and move on and go on to example number 1 of finding the volume of the rectangular prism. So go ahead and draw a rectangular prism. Take your time. These are not easy to draw. Okay, you're going to start off with the base of a rectangle. And then make your 2 lines on your left side. It is like a little hard for me to draw it on my tablet, but we got it. And I'm going to draw the height down the middle. I'm going to have the height be 14. I'm going to have the length and the width be 6 and 7. I'm going to find the volume of the following solid. So I'm going to write down the formula, which is 1/3. Length times width times height is equal to volume. I have 1/3. My length is going to be 6. My width is 7. And my height is 14. This is equal to volume. I'm going to do 6 times 7, which is 42. Bring down the 14th and the 1/3. I will do 14 times 42, which is 588 times 1/3. 588 times 1 is just 588. All over 3 is equal to volume. Put this in my calculator, and I should get 196 units cubed as my volume for the volume of a rectangular pyramid. Okay. If you guys have any questions, again, please write them down so that way next time I see you guys can ask me anything that, might be on your mind, or maybe something that came up when you guys were watching this video. I do have a worksheet for you guys, so I want you to work on this. But other than that, thanks for watching. I hope it wasn't too much, but good luck on your worksheet.